In previous courses, we have studied how to find the derivative of a function. Now we have to find the antiderivative. And the antiderivative is the inverse operation to the derivative. So, let's say we have a function f of x. Usually we find the derivative of that function, which is f prime of x. Now I will give you f prime of x, and I will ask you to find the original function, which derivative is 2x. So think a little bit in this idea. We have the derivative of the function, and we want the antiderivative or the original function, which derivative is 2x. I'm going to ask you to think a little bit, just 2 or 3 seconds or the time you need. So, but stop on the record and tell me what will be the function which derivative is 2x. Okay, you're ready? So you probably got to the idea that the original function is x squared. So if the function is fx squared, x squared, let me draw this. When the function is x squared, then the derivative of the function is 2x. That's pretty good. That's good. But think about this. What if the function is x squared plus 1? What will be the derivative of that function? The derivative of that function will be again 2x. And what if the function is x squared minus 1/3? The derivative of that function will be as well 2x. So we know that the antiderivative of the function is x squared plus c, where c it's an arbitrary constant that can take any value. Let's talk about the notation of the antiderivative. The notation of the integral, it's a sign similar to an S, but a little bit taller or flatter than an S. And as we usually do with equations, we have to draw the derivative or the, the antiderivative or the integral sign in both sides of the equation. So if we have dy equals to f prime of x times dx, now we're going to add the integral of dy, it is equals to the integral of f prime of x times dx. And so, for example, let's say we have dy equals to x prime times dx. So the integral of dy, it is equals to the integral of x cubed times dx. And once we have the integral and the differential, these two are opposite operations, so you can solve and you just have y. So y, it is equals to 1/4 of x to the 4 plus c. Let's see, if we have this y, let's obtain y prime. Y prime will be 1/4 times 4 x to the cube plus 0. So substituting or simplifying 4 and 4, you will have that a y prime is equals to x cubed times dx, or the derivative of y, or y prime. Let's call it y prime. So we have that y prime equals to x cubed times dx, which is basically the same function. So now we have to learn the rules of integration. There are 5 specific and principal rules to learn. The first is that the integral, we also call the antiderivative the integral or the indefinite integral. The integral of a constant times f prime of x is equals to the constant times the integral of f prime of x, where k, it's a constant that can be any number in the real numbers. The second rule is the integral of a sum, it is equals to the integral of the first function plus or less the integral of the second function. The third rule says that the integral of 1 times dx, it is equals to x plus a constant that can be any number. And then we have the fourth rule. This rule is very, very important because this is part of this is the rule that we use in order to obtain the antiderivative of the integral almost any function, and that is the integral of x to the n equals x to the n plus 1 over n plus 1 plus c. And the c is very important because you must add a c always. So what is this? This is just the opposite of the derivative. What we do with the derivative is that we multiply times the exponent of x, and then we subtract 1 to the original exponent. Now we're going to add 1 to the original exponent, and we are going to divide by the exponent plus 1. And finally, the integral of 1 over x, which is exactly the natural logarithm of x. So if you can remember, what is the derivative of natural logarithm of x? The derivative of that is 1 over x. So now we're doing the opposite. The integral of 1 over x times dx equals to natural logarithm of x minus c. I'm going to ask you to stop the video in this part and rewrite on your index card the 5 basic rules of integration. Okay, now that you have written the formulas, let's do an example. Okay, let's go to solve an example of an integral. Let's say we have this function, which is the integral of x squared minus 2x plus 5 times dx. Okay, I'm going to start first by writing the integral of the sum as the sum of the integrals. So I'm going to rewrite this as the integral of x squared times dx, and dx is very, very important. Otherwise, you wouldn't be able to obtain the integral of a function if you don't have the dx, minus the integral of 2x times dx plus the integral of 5 times dx. And that is the integral. What is the rule that I use? Okay, this is the rule that I use. The integral of a sum, it is equals to the sum of the integrals. Very good. Now, let's continue with our integral. I'm going to do this integral, and the integral of x squared, it is equals to x cubed over 3 plus a constant, okay? The rule that I use, and then I'm going to write all the integrals as, because I don't want to do them all in one step. I'm going to tell you what is the rule that I use in this step. This is the rule that I use, okay? The integral of x to the n equals to x to the n plus 1 over n plus 1. In this case, n was the coefficient 2. So I sum 1 to the original constant, which to the original power that was 2, and I get with 3 over 3, okay? The third step, okay, it will be x cubed over 3, I have already my integral there. Then I'm going to write the integral of 2x, it is equals to 2 times the integral of x times dx plus the integral of 5 times dx. So the integral of a constant times a function equals to the constant times the integral of the function. So this is the rule that I use. Okay. Then I'm going to do x cubed plus 3 plus s minus 2. The integral of x, it is x squared over 2 plus c. And that is exactly the same rule that I used in the previous step, in this step. And then I'm going to use plus 5 times the integral of dx, and then by using the last rule, so now we have that the original function is x cubed over 3 plus c minus 2 and 2 x squared plus c plus 5x plus c plus c. So what we have now is that we have several c's. c plus c plus c. But as c is an arbitrary constant that can take any value, we are only going to write one of those c's. So let's rewrite the function. The function was x cubed over 3 plus x squared plus 5x plus c. And this is my indefinite integral, my antiderivative, or my original function. The only thing that is missing is to verify that my original function, the derivative of my original function, gets to the first function that we have. So let's obtain dy, or the derivative of this function. The derivative of this function will be 3x squared over 3 plus 2x plus 5 plus 0, because the derivative of a constant is 0. So we have now that dy equals to x squared plus 2x plus 5 times dx. So if the derivative of the function is my original function, then we have done the antiderivative. We have found the antiderivative in a correct way. I hope you have found this very useful. I'm going to ask you to continue with the exercise on your notes first.